In this video, we are going to be focusing on problems that has to do with laboratory quality management, which we can also call it quality assurance and control in laboratory testing. We have the precision, accuracy, contamination. The first one, when we talk about the accuracy, if the result matches the true value, we simply feel free to repeat the experiment and compare the result with the non-standard or method to ensure they are correct or they are close. If you look at it here, what I have on the screen, those are like some protocols or rules which we need to follow in order to assure accuracy. First thing we need to do is to check if the measurements are close to the correct value. Secondly is to use the standard to make sure instruments are working right, and we also need to compare results with the non-values. Use the same method to measure things more than once and see if we get similar results. So, apart from that, we can also confirm the accuracies mathematically using percentage error and deviation. We said we can confirm the accuracy. Here we have accuracy. And we said we can confirm it mathematically using the percentage error. We are using the percentage error. And secondly, deviation. Okay, let's start with the first one. For us to confirm accuracy using the percentage error, in this case, the percentage error is simply going to be the experimental value. We're going to minus that or subtract that by the accepted value and divide everything by the accepted value. Then multiply everything we get by 100%. What about the deviation? The deviation, let's denote it with capital letter D. It's simply going to be the experimental value minus the true value. Experimental value, we're going to minus our true value. Second thing we have on the list, we have the precision. We are done with the accuracy. When we talk about the precision, what we are expected to do here is to simply look at how close results are to each other. After that, we need to conduct multiple tests and see if its outcomes are consistent. But if they vary a lot, if they vary a lot, it simply indicates that there is low precision there. So here, what we have on the screen, if you look at this precision, those are like some simple protocols which we need to follow in terms of the precision. Do things the same way every time and get similar results. Do tests multiple times and see how close the results are. And we can simply use the chart to see if the results are staying consistent over time. So if you look at it here, apart from that, those are some protocols which we need to follow. We can also confirm the precision mathematically using the standard deviation, and another way is CV. When I said CV, I simply means coefficient of variation. In this case, we're done with we're done with accuracy. We're going to see how we can confirm the precision mathematically. We said we can use it using standard deviation. The standard deviation is given by the square root summation of x minus x bar to the power of 2 divided by n minus 1. Apart from the standard deviation, another way is using the CV, which is coefficient of variation. The CV is simply going to be the standard deviation divided by mean. And we're going to multiply that by 100%. Or you can set our CV is simply going to be the standard deviation divided by mean multiplied by 100%. These formulas can help in quantitatively assessing the accuracy and precision of experiment data in laboratory. The last one which we have is contamination. This is simply what we are asked to do in contamination is simply to keep an eye out of the outside of the substances getting into our sample. Let me take a quick revision. I said when we talk about the contamination, this is simply to keep an eye out for outside substances getting into our substances. We simply need to follow strict protocols, use clean equipment, and regularly test for the contaminant to maintain the integrity of the sample and result. And if you are expecting me to give you calculation on this, contamination does not typically involve any calculation in the same way as accuracy and precision to do. Instead, it involves practices and procedures to prevent and detect the presence of foreign substances. But you can still use calculation indirectly to assess the contamination levels by measuring the concentration of the contaminant in a sample compared to the acceptable limit or standard. So this is it for this problem. I hope you find it very helpful. And here I forgot the last one. There are some protocols also which we have on the screen which we can follow for the contamination. The first one we have is keep things clean to avoid dirt or germs getting into the sample. We can also use clean equipment and containers. Test for unwanted stuff in sample by running black samples without any material. Follow safety rules and wear the right protective gear to prevent the contaminant. So this is it for this problem. I hope you find it helpful. Feel free to like, share, and subscribe. And under analytical chemistry, I also have some solved problems which you can check, like calculation of percentage weight by volume, weight by volume, weight by weight, and so on and so forth. Thank you for watching. See you next time.